right. Thanks, Dimitrios. And it's good to be back, I think, and to pick up from where we left off. Um, if you attended the morning keynote, there's a lot of talk about context, and we briefly touched upon context engineering and context infrastructure and all of these emerging terms and technologies and kind of like practices, right? So this is where we go deeper on this. I have an amazing panel with me, right? So I'll be brief in my intro. Vinoth, founder CEO at Onehouse, been working with data engineers for over a decade, and also been part of data infrastructure teams at places like Uber and LinkedIn before. I'm very, very excited today to welcome our panel, who are all, ML AI practitioners who, and I love to actually go deeper with them on this topic of context engineering and what does it really mean. So yeah, without further ado, let's maybe do like a quick round of intros for our panelists, starting with maybe David. Can you kick us off?
Hi everyone, I'm Dave Aronchick. I'm co-founder of Kubeflow, and I did work on Microsoft's open source machine learning strategy for several years. I now lead a company called Expanso, where we do distributed data pipelines, both ingesting, adding context from your data, no matter where you get it from, and then also running ML at the edge.
All right, amazing. Alex, do you want to go next?
Hey, I'm Alex. I'm the tech lead of the machine learning platform at Monzo. I've been at Monzo now for just over 2 years. And yeah, we work on everything from the whole like traditional ML to AI and kind of the whole end-to-end basically. And it's been a fun ride so far.
All right, amazing. Melda, do you want to introduce yourself as well?
Yeah, sure. So I'm Melda. I'm part of the Uber AI team. Been at Uber for 4 years and a half, so a bit more than Alex has been at Monzo. Doing kind of everything from kind of our DevX reliability work to we're doing some cool stuff in the open source, which we'll share more about later in the year. And also a lot of kind of the EU AI Act compliance stuff, both for core machine learning and AI, which has been an adventure. All right, over to you.
All right, amazing. So, all right, so we have actually relatively a short amount of time for the mountain of depth that we need to cover here. But here is how we'll frame this, right? So OpenXdata, unsurprisingly, is attended by a lot of data engineers and people who are data practitioners building data platforms, right? So I'm going to basically play that role. I mean, channel that voice, and I'm trying to kind of for our audience, trying to unpack what is really going on and what is context engineering, data engineering, and kind of like hopefully the goal is to leave with some good understanding of all of these, and also potentially like some areas for data engineers to focus on as the world, the AI revolution unfolds, if you will, right? So awesome. So let's kick off. Alex, I want to like start with you. We have ML systems for over a decade, right? I mean, it's not the first time we build machine learning systems. So what really changes LLMs? Is it just better models, or did something shift fundamentally now this time?
Well, I guess from like a data engineering point of view, and interfacing with the kind of ML folk who are kind of doing the modeling, like almost all of the time was just spent in sort of creation of data sets, of building out training pipelines, and then like an awful lot of time was just spent on like kind of the evaluation of those models that you were kind of training. And that was all around like feature engineering, and it was all around making sure that you create these large data sets and making sure you have these nice clean labels and stitching all that stuff together to then train these models. And that whole part has just been completely replaced. So you no longer, well, I mean, especially if you're using providers, that whole chunk of where a lot of that kind of time and effort was actually spent has now just kind of disappeared into just an API call. But I want to kind of suffix that with like, and maybe we'll get onto this a bit later, but like the same paradigms that you have in machine learning to determine like, I've made a change, how much has this affected the output, is still relevant, very much relevant. So it's like similar skill sets, but it's just that the where you place your time has changed quite a lot when you're trying to productionize these systems.
Right. Interesting. Interesting. Uh, from there, I want to go to you, Melda. Like, do you see this as a new stack, or it's a natural evolution of capabilities? What's like,
Yeah.
in your opinion, fundamentally different?
That's a great question. So Uber, we actually have our own machine learning platform that we've been building for the past 10 years. So it's quite timely and I think appropriate that. So we've had a lot of the core or what like classical machine learning components, which are like, ML specific. And then there's more just simply platform components like pipelines, stores, APIs. Those parts and kind of the control plane, a lot of that is very extensible. So I mean, this specific machine learning model, how you do your data engineering. I think that there's a lot now. We're going to talk about context engineering, so on and so forth. Those are kind of ML flavor specific. We use that terminology to determine, to distinguish between classic machine learning and kind of Gen AI, agentic AI. But a lot of the fundamentals are completely reusable, like especially when it comes to compute resources, like managing CPU, GPU clusters, Spark, Cray, like all of that a lot of it is quite similar. So that's been kind of, great for our team. But then there is, of course, additional work that you have to do to make things work in the Gen AI world, which is just completely net new, both from kind of the data engineering perspective, but I'd say a lot more also from like the serving perspective, and kind of those two getting a bit more mixed than they ever did before.
Got it. Got it. So there's a good amount of like orchestration and like platform like those parts you could reuse, while you need to pay attention to things that are fundamentally different about the models that we're dealing with, which are LLMs. Right.
Yeah.
So I'm curious, is this the Michelangelo system that you were referring to?
Yes, it is Michelangelo, and that is the platform that we are starting to open source. And kind of a lot of what we actually just discussed is guiding our decisions on what should or should not be open sourced, right? It's like these reusable components, a lot of just taking a model to production. That challenge is a challenge everyone is facing, whether you're doing core machine learning or classic or kind of Gen AI or agentic AI. So those components are kind of leading our charge to open source. But yeah, it is Michelangelo, and there's a lot of companion blogs that explain what it is. Yeah.
Yeah, I asked because I'm ex-Uber alumni, and I was there when we started it way back. It's great to see that progress. David, moving over to you. You deal with a lot of these like workloads in the flesh, right? So what is the hard part? Did the hard part previously used to be that you need to train a model, people spend a lot of time like fine tuning the coefficients and things like that. Now with pretty much the large the LLMs and foundation models, did the hard part move from training models to just the getting feeding it with the right context, or what do you see the challenge shifting?
Yeah, I mean, I think that both Maida, sorry, and Alex, I hope I got that right, touch on really important elements, right? Like, make no mistake that the quality of the models has significantly improved, very significantly. But I remember in 2018 there were models that could beat I think every like Atari game, right? On its own. You could train it to figure out how to like learn new strategies and things like that all on its own. And AlphaGo was 2017. I mean, these are like groundbreaking, revolutionary models back then. That's not to say there haven't been advancements, but I would argue that a lot of the advancements are around the UI, right? And the actual interface, right? We're so far abstracted from understanding how to fine tune and what your final layer is and one hot encoding and yada, yada, yada. Like, nobody has to think about that in order to get good answers. Now, directly answering your question, I would say one of the biggest failures today is assuming you can ask a model something, which again are borderline, superhuman in their capabilities. You can ask a model anything, and it will have any kind of context around what you're asking it. One of the biggest challenges that we do in our data pipeline world, and I don't want to talk my book, but is just show people hey, you know what, you put all this data into this warehouse. The model has access to that warehouse, but you in your head maintain this context, organizational context, business context, whatever time, oh, you know what, no one would ever go shopping on Sunday in whatever France. I have no idea, right? Like, that's a context you have that the model just does not have awareness of in for what you're asking it. And so you give it this question and it comes back with a generic answer or whatever. And so that, I think, is missing as much as anything. And we just help, we help people all the time, just say like, hey, you're already moving this data here, just wrap it with a little bit more information and you're going to get better answers.
Got it. Got it. So that's interesting, and I think it's at the crux of the context engineering topic, right? So we know what data engineering is, right? We build the first part of what you said. We build pipelines. We've been like building pipelines and tables, and put it in front of analysts and data scientists for various reasons for a while, right? So, and when you say like when you're helping companies become AI ready, what is that extra bit of information that you actually add? Can you like make it super concrete for a like a data engineer to understand that here is how I ingest the data? Is it like extra information that I ingest? Is it a better catalog? Is it like better documentation that you semantically parse and associate with? Like what is it? What's the
Yeah.
context?
Sorry, was that question to me, or I'm happy to
Yeah. To
okay.
you.
Yeah, it's incredibly boring, everyone. I'm really, really sorry. Like the most common thing. So I always give this example, and it's totally true, and it basically mimics. Actually, I'll give you a real world example, but with the names left off. We do a bunch of work for example, energy companies. Energy companies have giant wind turbines and on-site solar deployments, or wind turbines, or whatever. They have these wind turbines take months to go and install and ship over from wherever their original location is. The firmware in those wind turbines is often different. It's often specific to the wind turbine. And they might have different teams and things working on those various things. And so a lot of times you will get a situation where like they'll change the order of fields based on the firmware version, and the firmware isn't shared between each of them. And so like one looks like it's dying and the other one doesn't. And that's just pure schema and data cleanliness, right? That's like the most boring thing in the world. But you can't possibly ask an AI to figure it out when you as a human can't figure it out, right? And to give you a even further context, so that's just cleanliness, and that's something we do help with a lot. But again, you can write this yourself. We just happen to write a platform that helps you do that. But it makes your models perform much, much better. But here's the second one, and even more subtle that I didn't even aware. So imagine you have a field of wind turbines. All the wind turbines, one wind turbine is working, and it's working at whatever, 80 kilowatts per hour or whatever it is, right? Then the wind starts to pick up, so they decide to turn on other wind turbines. Well, it turns out that their first wind turbine actually will go down in production. It'll go from 80 to whatever, 60, because the nature of wind is such that you can't infinitely consume all the wind. You can only consume as much as necessary to push the blade through, but then it has to go through. So they have to balance all these simultaneously. So now, even though the wind has picked up, because you turned on these other turbines, the first one goes down. Now, if you're operating with no context whatsoever, a human being or an AI are both going to say, well, shit, this one is now performing worse, even though the wind is higher, we better go repair it, right? Because they don't have context. And that's such a fundamental thing that's missing. So, while we absolutely do like full ML and do RAG and do all sorts of like fancy things, the first thing that we usually implement with folks is just like, hey, what are you doing as far left as you can with your data to wrap it, to provide governance, to provide metadata, to do schema enforcement, to merge it together and land it in the right place with all the information that it had when it left.
Got it. That's pretty interesting, and thanks for taking us through like a concrete example of what that context could mean and what could be lost without that, right? Melda, could you maybe like you must have a lot of these challenges at like very large scale, right, within Uber yourself, right? So how do you guys manage context, or like how do you collect it, how do you curate it, how do you know, for example, like the right things are captured from the right people in the business and can be fed to the AI system, right? So can you help us unpack the hard parts of doing this in real life?
Yeah, no, that's a great question. I think I just want to spend a second to uh, explain maybe fundamentals between data engineering and context engineering, and like that will lead to the core challenges. So with data engineering, like I used to do a lot of machine learning before. You can really look at your data and know how good it is to an extent, right? We have like it's a tried and tested field. You like clean up your nulls, you can like do some transformations, and you're like,
Mm,
okay, this is now healthy. It can get into a model, like I'll split, train test, run it, like do whatever evaluation you want to do. And it is somewhat objective. Like that whole pattern is very difficult to replicate, or it's not really possible to even replicate in a kind of more Gen AI, agentic AI world. Everything, if you're not building a foundation model from scratch and you're not fine tuning a model and you're trying to figure out a way to use a model in some production system, kind of everything needs to go in that context window. And it's not just
right.
about stuffing all the relevant information. So from a data engineer perspective, first, what is the relevant information? Making sure it's readable by the system, which is different than how it could be readable by a human. Like just
Right.
simply, I think we all get a bit lazy at, making sure our column names, our feature names are nice and readable. Like if we have everyone can create data set at Uber, and at some point it just becomes abbreviations. I have no idea what it means. I know I can ask that data set owner, hey, please go and like clarify it. I usually don't need
Mm,
to. AI
mm,
will not know. It will make some assumption if it's retrieving that data on like what
right.
this feature is. So there are all these like fundamentals that we never got around to that we just need to think how in this very limited context window do we, fit the prompt? Do we get the right context that's needed, be it more kind of text, semantic data versus like whatever the data is, but making sure it's correct. Like how do we know it's correct? And it's hard to know until you've actually run it. And then, I
Right.
mean, if you're doing it right, you have invested time into like a labeled golden data set where you can say, okay, I'm using this AI model or this like production system for a very specific use case. Like I think we need to clarify it, right? If you're not building a foundational model, you're telling this thing you need to do one thing and one thing only. So you have something that you can evaluate against. Doesn't look good?
Mm,
Okay. Is it data problem? Is it a retrieval problem? Like, are we retrieving the right data? Is it a chunking problem, right? What if it's like massive legal documents and like things, the chunks don't, like the chunk that's retrieved doesn't actually have the exception to rule number, whatever. What if documents disagree? You have two documents, two legal documents published by one an EMEA legal team, the other a US legal team, and they just contradict each other, right? Like that case doesn't happen in classical machine learning. Here, this Gen AI model, based on the prompt you gave it, is trying to figure out how do I reconcile these two and put it together. So when it comes to like data engineering in the Gen AI world, it's
mm,
really about thinking about how you can write instructions in human language for a machine that will be
right.
confidently wrong if it is wrong or confidently right. So it's just this whole setup is different. But just to wrap up here, a lot of the fundamentals of like data quality, you know, all of that is the same, but just figuring out how do you apply it to a world where it is a machine that is acting with extremely basic instructions, acting, not like a human who looks at obvious things and will know this is the right data set, this is the right wrong data set, so on and so forth. So, I mean, just to wrap up for the answer at Uber, you have to invest in each production data set, figure out what is essential for that use case, make sure it had access to that knowledge. So again, not sexy work, but it does have to, you do have to do it.
Got it. Got
Yeah.
it. And the upside of the sexy work is that there's an AI agent that can probably make us a lot more efficient. So okay, all right. I like grounded answers. So it's super awesome. Alex, I want to shift to you a little bit, and Melda mentioned the all important context window, right? So maybe can you maybe just explain that a little bit from how you see from a data engineering versus context engineering angle. Do you feel so we used to just pre-compute data sets. From that, do you think the challenge is moved on to assembling the right data at query time, which means you need a lot more flexibility to assemble the context? Or can you talk about, maybe share with people what that looks like? Let's say I have a query, natural language query to an LLM, and then you want to assemble context to answer that query at runtime. What is involved in that process, do you think, that is different from regular database queries?
Yeah, I think it's a great question. And I'm going to go on to the similar theme, right? And I guess this is the whole point of this panel, which is typically we reach for the same tools that we're reaching for the sort of like traditional ML use cases, right? So like context and features are like somewhat quite similar context, like concepts, right? So, a model, when you're making a prediction, you're going to have some inputs to it. And those inputs, okay, it comes in a different form, but they're typically like aggregations over something, or maybe it's like the top K of something or the last X of something else. And typically it's like, these are the inputs and I want to then pass that in and put it into the right place at the right time. The place changes, right? Where like within model, when you're doing like traditional ML, it's like these are the inputs to the models. Where within context engineering, it's like within the prompt. So you're just going to like structure these into the string prompt. But fundamentally, you're still having to do the same thing. So maybe if you're trying to say like, okay, yeah, what are the last X transactions you've done to a particular merchant in like Monzo's case? Well, that requires us to still be processing events off of Kafka. It still requires us to be doing aggregations on those events. It still requires us to be doing that efficiently, using the sort of like with low latency and all the kind of good stuff we normally expect. And then also like when evaluating these systems, again, going back to the same idea that actually we can reuse a lot of the same tool sets, like creating, like if you have to assemble context in real time, well, in order to evaluate how well your model would have behaved at a particular point in time in the past, so you can try and understand, like, if I make change X, then this is how my model would have performed, or my system would have performed with the context it had at that moment in time. Well, we have to do that same problem when we're training like ML models, right? Which is, we have to take the historic data we have to create the context, or in ML case, the features with the correct like point in time, so you can kind of replay those back through your agents and then sort of take away some of the non-determinism that you have in this sort of in using these providers or Gen AI models, and try and kind of like harness some of that into using your historical data to push through some of those pain points.
Got it. Quick follow-up. Do you think the non-deterministic kind of nature of what an LLM might do would increase the need for an underlying data platform or a Kafka or something to be a lot more flexible in terms of these context queries that it may receive at runtime, or
Yeah, and I
compared to a
think
traditional model?
in a way, but like so within at Monzo, we've put a bunch of investment into this tool set that we call the feature transformation framework. But basically, it's the open source framework called Chronon, and that's actually quite and we have that kind of like put through our system. So in terms of the tool sets we use, it's like it's pretty easy to describe quite complex aggregations of inputs and outputs to models, and then also have those backfill, so you can kind of back test your changes against historical data. So again, coming back to the point of like, does the tool sets fundamentally change? I think probably not from our point of view. With us at Monzo, like the things that actually fundamentally are changing is more around like less on the data engineering side and more around like, okay, we have this external provider that we're going to be like pushing data to, and it's they're unreliable, or we want to have failovers to different models, and we want that to be transparent to our users. But from a data point of view and evaluation, like offline, the tool sets are very, very similar.
Got it. Awesome. So, David, circling back to you a little bit, just to have this some closure to this part. If I'm a strong data engineer today, and then I'm tasked with, hey, the data that you're building, the pipelines that you're building are going to feed AI agents and feed to be potentially used as context for AI agents. What's one or two things that I should be learning in the next few months to be effective in this world? Like my consumer is no longer human be like, I mean, like, it's a human, but it's also like I'm building data for queries that are automatically generated from LLM. So what should I upskill myself?
I mean, again, I'm just going to steal from smarter people on the panel than me. It's going to be the same old, like initial data engineering stuff. The cleaner you can get your data, again, it just in the same way you would appreciate clean data, your model will as well. Having the right context, having the right provenance and lineage, making sure you know where the data came from. Even after it gets tossed into the term I've been using is data goulash, because it is totally non-introspectable once it's in there and it's been trained on, is critical. But also, like, a lot of these things are the same old tools. Use the things that are battle tested, because there's so much history and lineage around them that, like, there's nothing preventing that. What I will say, as an extension to everything that you heard earlier, is these things are AI agents. Even if you wrap them with a rich memory system, at least the first query, if not more, are going to be stateless, right? So the more that you can put in there, you want to put exactly as much as it needs to answer the question and not more, because you'll blow out your context window. So, like, how you walk that fine line is up to you and your business. Think about that. Think about all the things that it needs to have access to in order to make these good decisions, and make sure you make it available. But also think really, really hard about what you're losing as data flows through your system, right? So if you have a point of sale system in some location, or you have a user that interacted with a website in some location, you pass it through, as it goes from there to your Google Analytics, to your user reference data endpoint, which you then resolve into a user ID, and so on and so forth. And now at the end, they're trying to make a decision on this user, but they didn't realize that this user was accessing from, I don't know, Bangladesh. Like, that data is going to be lost along the way. So the more that you can ensure that data is encapsulated and carried along so that you can make a decision at the end, I think that's just incredibly important. And those are the kind of decisions that once they're, if you don't start doing it now, it's lost forever. You will never be able to go back and get it. Sorry, go ahead.
Got it. Awesome. That's actually very, very actionable. And I know we're like running super low on time. Maybe, Demetrius, we'll have a couple of minutes for Melda and Alex to share some closing thoughts.
For you guys, anything.
All right. I'd love to hear any problems that you guys feel like, oh, these are interesting problems I think will be solved in the next few years. Anything worth highlighting, that'll be awesome to hear. Melda, do you want to go first?
I feel like you need to think about that for a second, but I'll think while I talk and say that I think that the data engineers are uniquely positioned compared to a lot of other folks in the ML ops world. Like, AI has been so democratized that you're just like, everyone's vibe coding these days and doing whatever. I think data engineers have this rigor, know how to think about data quality, data lineage, things like that. And those are real issues in kind of Gen AI and production. So bring that mindset into these spaces and like voice your opinions to solve the hard problems that need to be solved.
Right, Alex.
Nice. Yeah, I'll keep mine short. But I think it's all around this idea that the sort of promise is that you have all of these, you can use Gen AI and you have agents, and there's this idea of context. But I still think, like, especially like people I've been speaking to and what we have in Monzo, there's still this idea of like, there's just not enough context available and not enough like things for these agents to be able to do. And there's still just a lot of just work to get to that point where we can like let these things kind of, well, maybe roam free is a little sort of over the top, but I still think there's a gap there. And so it's, yes, the models will keep getting better, but I still think like, companies have just got a long way to go until they've reached that kind of utopia of just all context and all actions available all the time.
Yeah, context is the bottleneck. All right. Back to you, D.
Well, thank you all. This was very insightful, and I love every minute of it. I also want to call out David. I think you're blurring your background, but there might be some instruments back there, huh? If I see correctly.
No, the exact reverse. It's like a podcasting thing. I do a lot of live what do you call it? So could not be less cool. There you go. Right.
Oh
Play-
no! You should have just kept it blurred. And kept
I
it
play
in-
guitar, but it's in another room, and I'm terrible. So that like I'm glad I didn't show because that
All
would
right,
be
get off the stage then. We'll see you later. This was awesome, folks. Thank you all. Alex, Vinoth, and Melda, thanks for this. I'm going to keep us moving because